Example number 3 is different because it has the word solve. It does not have the word prove. If you tried to prove this, it would be impossible. Okay, so make sure you read the instructions. When it says prove, then you have a proof to do. If it says solve, this is an equation just like you've had equations in the past. How do I solve equations? And we had one of these in chapter 6. Had one on our quiz. Well, in this case, in this equation, we have cos and we have sine. Right? We have a cos x and a sine squared x. So we can't solve this because we have two different trig functions. If there was a way that we could rewrite this, possibly using one of our identities, so that there was only one trig function, then we could probably solve it. Is there a way that I can change either the cos to sine or the sine to cos? I can change the sine to cos, but I can't change this cos to sine. Why? Right. We can use, right, we're going to use this big idea, right? Sine squared plus cos squared is equal to 1. And that is only true if they're both squared. You can't say sine plus cos is equal to 1. It's only true if sine squared plus cos squared is equal to 1. And so if I rearrange this equation, I can rewrite everything here. But instead of sine squared, I'm going to write 1 minus cos squared. Then I only have cos instead of cos and sine. And what kind of equation is this? If I distribute that -2,
Quadratic.
it is a quadratic equation. How do I solve quadratic equations?
Just factor it.
You have to factor. So are you okay if I write the, it's probably easiest to factor if this is first. I need to combine like terms, so I still have minus 3 cos x. 3 minus 2 would be plus 1. As far as factoring ones go, in my opinion, this is the easiest one to factor because the only way to get 2 cos squared is to have 2 cos and cos. The only way to get 1 would be to have 1 and 1. And the last thing you have to decide is there going to be 2 plus signs or 2 minus signs. Check your outside is 2, your inside is 1. I need a minus 3, so they'll both have to be negative. I always do a quick mental math check to make sure that that multiplies out to equal what is above, and it does. And so we get cos x equals positive 1/2, or cos x equals 1. Are those on your unit circle? Yes. When is cos equal to 1/2? Somewhere. Pi over 3? And somewhere else? I like that. What quadrant?
4.
Quadrant 4. So 5 pi over 3? Nice. Love those answers. Somewhere and somewhere else. Good. Multiple choice. The answer will be A, B, C, or D. I'm sure of it. Right. I'll do that right after. So good noticing that the domain is different. But one of the things that you sort of get used to is you sort of get used to solving quickly between 0 and 2 pi, and then I'd like you to check that domain at the end. So if I did this side, when is your x coordinate equal to 1? At 0 and 2 pi. So we've solved it between 0 and 2 pi and included all of those values, but now we will go back and do a quick check. What is our domain? Our domain is between 0 and 3 pi over 2. Can you see that that's only quadrant 1, quadrant 2, and quadrant 3? So any answers in quadrant 4, you'll have to take out. And 2 pi is too far as well. So the only answers to this one are something and something else. Yes, perfect. Yeah, I'm recording. Pi over 3 and 0. Perfect. So, question number 10. We'll ask you to do something. It's good for practice.